Hey guys, and welcome to your first SYSC 2100 lecture. It's Taz, and I'll be here to help you today. So, what is recursion? It's simply solving a solution by breaking it down to a smaller scale and then solving from the ground up. So after you get it down to its base state, so like the very bottom, you then go upwards to solve it. There's actually two types of ways he taught us, and one is sequential searching, which is pretty basic. You start at the beginning and you finish at the end, and you search for everything sequentially, essentially. The next is binary searching. Well, this one is a bit different. Example is, here's the beginning, here's the end, and you start searching right in the middle. Then you decide, do I want to take the left fork or the right fork, or vice versa. Now, there's some things about a recursive function that's important. The function itself calls itself, and it develops the answer from the base case. That's an S. Case. Alright. And here is the most basic and overused factorial. And I'm going to assume you know Java programming, so I don't have to go over this. But this is the only line that is kind of interesting. Well, these lines are the only lines that are interesting. This is your base case, where if n is equal to 0, it actually returns a number. Else, it returns this. Now, if you're confused of how this works or why it works, I drew a little thingy. So assuming n is 3, we're going to go through everything until the base case. Well, if n is 3, it says it returns n times factorial 3 minus 2. This whole function I just called it fact. So 3 minus 2, 3 minus 1 is 2. Hence fact 2. And then you go to n2, because now it calls factorial again with a value of 2. It returns n times factorial 1, because 2 times 2 minus 1 is 1. So then you call factorial n is equal to 1, and it returns n times factorial 0, because this statement has not been reached yet, because n is 1, not 0. Finally, you call n times factorial 0, and when n is 0, you return 1. There we go. So you return 1, and this gets put right over there. So then you have 1 times n, and now you can actually return it. So 1 times 1 is 1, and then this gets returned over here. And n is 2 in this case, and you have 2 times 1, which is 2, and that gets returned here. And n is 3 in this case. And 3 times 2 is 6, so your return is 6. And let's do a little quick check, which I did beforehand. 3 times 2 times 1 is 6. Bang, bang, boom, and you're done. I took this directly off his slides, but this is what you have to ask yourself every time you get a recursive problem. How can you define the problem in terms of a smaller problem of the same type? Well, in the recursive function, this is how we did it. How does each recursive call diminish the size of the problem? Well, every call, we reduced the value of n by 1, so eventually it would have to reach the base case. What instance of the problem can serve as a base case? This one for factorial was pretty simple just because it's already defined in math. But you really have to do, this is probably one of the hardest ones to think about. Obviously it's going to be the one that's smallest as possible, but what's the equation? Well, don't worry about that. We're going to go over tons of different recursive problems, and I'll explain them all the way. And finally, the last question. As a problem size diminishes, will you reach this base case? Although this seems kind of redundant because you're finding out the base case, some people actually forget to even think about the base case, and sometimes it's not reachable just because of how the function is. So make sure you answer all 4 of these questions before you actually start programming it. Other than that, thanks for tuning in, and I'm done recursion, and I'll see you in the problem questions. Peace.